Hello, my dear children. How are you? Welcome to one more amazing session from Infinity Learning YouTube channel. So, am I audible? You all can see me, can hear me. Just give me a confirmation. Yeah. Welcome to one more amazing session. So, in this previous week, we had various strategy sessions for how to crack NEET and various CBSE versus NEET preparation. Now we are going to discuss about the topic wise discussions in this particular week. Like you see, isomerism. Whenever you just see a question paper, the isomerism concept is blended with the other type of concepts, so that you will be understanding what type of these isomerism concepts can be given to various conversions. Some reactions are stereospecific reactions, some reactions are stereogenic reactions. So you need to understand various isomerism concepts in order to go ahead with that. So my dear children, you please give a thumbs up and fire emoji before you go for the actual class of discussion. Right. Before going for the isomerism, a small promotional slide. Bacho, Betu is there in the class, Sonali Gope is there in the class. Okay. I really appreciate those students who are regularly coming to the classes. So this isomerism I want to make into the two parts. One is structural isomerism, another one is stereoisomerism. आज हम चर्चा करने वाले हैं structural isomerism. So before going for this session, I just want to give you a NEET test series promo here. Students, whenever you are preparing for some examination, it is important to know what you are doing and how you are doing, where exactly you stand. For that, you need a proper assessment platform. This assessment, hi Sonali Gope, hello, good afternoon. I was saying your name because you are the regular student, you and Betu and other students. And one more student is there, I forgot the name also. Okay, anyways, let's interact. Those who are online, please like the session and share with your friends. Subscribe to Infinity Learning YouTube channel. Here, NEET test series is an assessment platform. This assessment platform, hi Vijaya Bhargavi, good afternoon. So rather you say good noon or good morning. No problem here. This test series is prepared by the assessment team and eminent faculty from the NEET assessment team platform. And this gives, it is designed in the basis of latest NT examination pattern. And also it gives a real-time simulation for the examination, so that when you are writing examination, you will be understand exactly where. So you feel it is as easy you possible, right? So it is ultimate key to NEET success. It is separately prepared for 11th standard ka, 12th standard ka, and a repeaters copy. Depending upon your category, you can change, and in the description box, the link is available. You click that link and just go ahead with that. And और एक चीज़ है, whenever you purchase, you just apply YouTube 30 off. A simple coupon code if you add ना 30% ऑटोमेटिक डिस्काउंट आपको मिलेगा, जहाँ पर जाओ डिस्काउंट भी मिलेगा, right? So this is about the NEET test series beta. And moving ahead, our scenario is in isomerism. Iso means same, mer means molecule. The molecule having the same molecular formula but differ in their properties due to their structures, and they differ in the properties. That is given as an isomerism. A small animation is given for that. So you can see a linear chain, make it a branch here, and you're going to get a branch 2-methylbutane. Okay, N pentane 2-methylbutane become, you're going to get 2,2-dimethylpropane neopentane, like that. So when you practice the isomerism problems, you are going to see this kind of operations, right? So let us see. So phenomena of existence of two or more compounds possessing the same molecular formula differ in their properties are called isomers, and the phenomena is called as isomerism. You like it? Sonali kept quiet, why so? So I want to see. So moving ahead here, so let's see various types of isomerism. Isomerism is broadly classified here into structural isomerism. This is also called as a constitutional isomerism and the stereoisomerism. What is the basic difference between the structural isomerism and the stereoisomerism? Bacho, here the structural isomerism. Compounds having the same molecular formula but differ in the structures are called structural isomerism. So they differ in the length of the chain, they are called chain isomers. They differ in the position of the locant, is called position isomers, and they differ in the nature of the functional group, they are called as a functional isomerism, and they may change in the ring and the chain isomerism, metamerism and tautomerism. Dear children, here most of the students experience problem here only. So I want to give more emphasis on the tautomerism in today's class. Bacho, right? So let us move ahead here. So example, structural isomerism. So you can say this is N-hexane, 2-methylpentane. What makes the basic difference? You have to observe. Both are having C6H14. So today's class is very much helpful for those students who are preparing for NEET, चाहे आप 11th standard भी हो सकता है, 12th standard भी हो सकता है, you can be a repeater as well. That gives a lot of impact. So you have the straight chain, it differ in the structure in this way. You can say they are chain isomers. And also you see, what are then stereoisomers? What are then stereoisomers? The isomers which have the same formula but they differ in the groups around the space. In the stereo means space isomerism, you can also say that. Okay, Vijay Bhargavi, hope you are understanding. Those students, please, if you have any doubts, please ask us. So it is a live interactive session, a radio session bhi nahi hai. So let's see the stereoisomerism. You have 2-butene. So it is going to have methyl group on the one side of the double bond, methyl group are on the opposite side of the double bond. So they differ in the geometry, right? So they are called geometrical isomerism is a part of a stereoisomerism. Okay, we'll discuss the difference in the properties also. So this is actually the introduction about the isomerism. But so here you can see, coming to the structural isomerism. In that structural isomerism, you have first category is chain isomerism. This is also called as a nuclear isomerism. The compound having the same molecular formula and the same same nature of bonding, but they differ in the length of the carbons. So carbon skeleton. Carbon skeleton may be in the principal carbon chain, may be in the branch. So different number of carbon atoms in the main chain or in the side chain or can be in the both. When I am taking the class, you just take, these are the catchy points. When you attend any lectures, you understand, but the catchy points are there. It is very important, my dear children. Talking about various examples. C4H10 hai na? You have butane, 4 carbons are there in the parent chain. If you say 2-methyl propane, 3 carbons are there in the parent chain, but they both have the same molecular formula. They are said to be chain isomers. Again I am repeating, chain isomers or the isomers differ in the length of the chain, maybe in the parent chain, maybe in the branched chain. Okay. Now moving ahead, example pentane, C5H12. Okay, Vijay Bhargavi and Anuj Gope. C5H12 has C5 carbon atoms together as a chain and 4 carbons together as a parent chain and 3 carbons together as a parent chain. So these are the various carbons. Understand? And moving ahead, hexane and 2-methylpentane, C6H14. You are going to have different parent chains with that. So it is very, very, very important, beta. Vijay Bhargavi, any doubt? Hope you like these slides. Enjoying? My dear children, this is a live interactive session. So this live interactive session, senior faculties are teaching in this YouTube channel. You can use advantage of this, and it is not a radio telecast session, it is a live interactive session. You can ask anything in the class, so that automatically all the questions we are going to discuss with you, right? We will be helping you in the journey of your NEET examination, right? That's good, love it, perfect. Now bachcho, moving ahead, one more example beta. Position isomerism. So this is about the position isomerism. Compounds having the same functional, compounds having same molecular formula, same nature of bonding, same carbon chain. Condition is same carbon chain, but differ in the position of the locant. This locant could be a position of the double bond. This locant could be a position of an atom. This locant could be a position of the functional group that is attached to the parent chain. So you can see it should be, the carbon skeleton should be same, and the differ in the locant. I want to give you an example here. Look at this. Look at this. But C4H8, but 1 in and but 2 in. So 4 carbon atoms are there. On the first carbon, double bond is there. That is but 1 in or 1 butene. And the double bond is present on the second carbon. So the double bond is on the first carbon position, double bond is present on the second carbon position. They differ in the positions. Is an example of the position isomer. And also you take this 1 chlorobutane, 2 chlorobutane. So if you say this is your butane, 1 chlorobutane and 2 chlorobutane, this is your butane, 1 chlorobutane. Bond line notations also will be given here. And you can say benzene diol, C6H6O2. You can say OH group is on the first position, second position, third position, fourth position. So 1, 4 positions. You can take first position and second position, 1, 2 positions. These two are position isomers. I want to talk about this is your benzene bachcho. I want to make it is 1, 2, 1, 3 and 1, 4. You take 1, 2 dichloro, 1, 3 dichloro, 1, 4 dichloro. It is ortho, and this is said to be meta, and this is said to be para. So with respect to 1, 2 it is ortho. अभी इडली नहीं खाया सर, इडली के बारे में बात करने का है. Okay, so when you keep quiet in the class, I don't feel that you are in the class. Okay, when you keep talking in the class, I feel directly that you are here. Now these are the same compound, same molecular formula, differ in their position. So they are said to be position isomers. Talking about, you just see this is the compound. If this is called a position isomer and this is going to be chain isomer, it is an illustration I just want to give you. Don't break the limb and show it here. Okay, and moving ahead, so functional isomers, compound having same molecular formula but differ in the nature of arrangement of the atoms. So that what will happen, you know, the functional group is going to be changed. So compounds having the same molecular formula but differ in the nature of functional group are said to be functional isomers, and the phenomena is said to be functional isomerism. Look at this. Here C2H6O, you can have CH3, CH2OH, it is an alcohol functional group, and CH3O CH3, Vijay Bhargavi, it is going to get ether functional group. मैं क्या बोलना चाहता हूँ, alcohol and ether always show functional isomerism. Fine. And you see example C3H6O. You have propanone where ketone is the functional group, and propanol you are going to see the aldehyde is a functional group. Ketones and aldehydes show functional isomerism. So always carbonyls usme ketone and aldehydes show functional isomerism. That's very important here. And you can also see C2H4O2 ethanoic acid, you are going to see the carboxylic acid as a functional group. And methyl methionate, you can see what is the functional group here. Vijay Bhargavi, what is the functional group I can say here? Yes, it is going to be ester. This is an ester. मैं क्या बोलना चाहता हूँ here? Always alcohol and ether show functional isomerism, and here it got ketone and aldehyde, and the ketones show functional isomerism. And also you see acid and ester show functional isomerism. Okay, so these are the various functional isomers that you can say. And amines are showing functional isomers. It's really interesting. Amines, what is amine? Bacho, here it is going to be ammonia. It is going to be ammonia. अगर अमोनिया एक हाइड्रोजन अमोनिया से हटा के एक अल्काइल ग्रुप बना दिया, so this is what is called as a primary amine. If two hydrogens are replaced, you can say it is a tertiary amine, second degree amine. If nitrogen, 3 hydrogens are replaced, you can say it is a tertiary amine. It is going to be tertiary amine. So I wanted to say the formula could be same. The primary amine, secondary amine, tertiary amines are going to be the functional isomers. So C3H9N, propanamine, it's a what category of amine, Bhargavi? It is a primary amine. Whenever NH2 primary amine, NH secondary amine, N is tertiary amine. So here N-methyl ethanamine, it is going to be a secondary amine. It is going to be a secondary amine. Whenever you see it is going to be tertiary amine, it is going to be a tertiary amine. So primary amine, secondary amine, tertiary amines show functional isomerism. है ना? Clear? Fine. Any doubt, बच्चों? That's good. So let's see. So the basic strength of amines also very important. So general organic chemistry में आपको पढ़ाना चाहता हूँ मैं. Next, you see alcohol. So aromatic alcohol, benzyl alcohol and phenol. Wherever OH group is directly attached to the benzene, that is said to be phenol, right? And OH group is not directly attached to the benzene. So जिस carbon atom benzyl carbon बोलना है, so you can say it is a benzyl alcohol बच्चों, and it is going to be 2-methylphenol cresol, orthocresol. The name of the compound is orthocresol. Both will have C7H8O. They are going to show they are said to be phenols and alcohols or functional isomers. क्योंकि ये प्रॉपर्टीज इससे अलग होगा. से एन एग्जाम्पल न्यूट्रल FeCl3 is added, ये रिएक्ट करते, ये नहीं रिएक्ट करता, ताकि आपको बोल सकते हैं केमिकली दे आर डिफरेंट. राइट? एनी डाउट बच्चों? Now moving ahead, examples. Cyanides and isocyanides show functional isomerism. So Cn is a cyanide. This is called isocyanide. And it is said to be isocyanide जब आपको nitrile बोलते हैं. This is also said to be nitrile. Whenever NC you say isocyanide, is also said to be isonitrile. I am very concerned about the students. You are a very good student, you study well. Brush. What is brush? With brush, build with brush. You are a painter. You are a very good student here, बच्चों. You study cyanide and isocyanide. लेकिन इसका नाम भी अलग हो सकता है. Cyanide is, according to IUPAC name, it is a nitrile halo. Here it is isocyanide is also called as isonitrile. So ethane nitrile, C2H3N, you can say ethane nitrile. You can say methyl isocyanide, CH3NC. Dear students, have you ever heard about this? Methyl isocyanide. रेलवे मैन मूवी देखा, उसमें मिथाइल आइसोसाइनेट भोपाल ट्रेजेडी में ये गैस लीक हुआ. So India's biggest disaster, I can say that. Okay, unit carbide, ये industry से निकला, is very dangerous gas. It's the biggest tragedy. Okay, talking about ring chain isomerism. Ring chain isomerism. Compounds have one isomer has a ring, another is an aliphatic chain. Ring chain isomers are also considered to be functional isomerism. So what is this? Ring chain isomerism and functional isomerism. You take C3H6. So CH3, CH double bond CH2, and you can also say CH2 and CH2 and CH2 and like this. So it is open chain and it is ring. Alkene and cycloalkane always show ring chain isomerism. Okay, bachcho, build with brush. Okay, Bhargavi and Anuj Gope. So if you have any doubts, please let us know. Moving ahead here, C3H6. मैं अब भी आपको बना के देखा. It is going to be like this and it is going to be like this, है ना? And also you can take a C6H12 and it is going to be hexene. So this is going to be hexene and it is going to be cyclohexane. Both are having the same molecular formula and they are going to get different structures as well. Okay, any doubt, Bacho? Now moving ahead, compounds having the same structure, metamers, that's very important. Confusing. So the compounds having the same molecular formula, same functional group we have, but they differ in the nature of the alkyl group with respect to a polyvalent functional group. ये मेटामेरिज्म एग्जिबिट करने का जो कंडीशन आता है, द फंक्शनल ग्रुप शुड बी एटलीस्ट बाइवैलेंट. जैसे आपको कीटोन से, ईथर से, थायो ईथर से, अमाइड भी हो सकता. यू सी एन एग्जाम्पल, द पॉलीवैलेंट फंक्शनल ग्रुप shows the metamerism. Can you somebody tell me what is the functional group here? What is the functional group here? Ester. It is an ester, bachcho. You know, this is an ether and this is acid anhydride. And this is the ketones. Whenever these functional groups, such functional groups are coming, you can say they are showing functional isomerism, metamerism here. Moving ahead, Say an example, polyvalent functional group, you are going to see it is going to be a secondary amine. It is going to be tertiary amine. It is going to be amide. Many of the students has this kind of doubts, which will participate, which will not participate. It is also said to be secondary amide. It is said to be thioether. This is thioether. Ether, oxygen is there. In the place of oxygen, if sulfur is there, you can say it is a thioether. Got it? So, moving ahead here, one more. So, metamers, ethoxyethane, you can say ethoxyethane, CH3, CH2, O, CH2 and CH3. This is ethoxyethane, and this is methoxypropane. You can say CH3, CH3, CH2 and CH2. This is a methoxypropane. उसमें आप देखने का बोल सकते हैं 2 कार्बन्स थे, ईथर 2 कार्बन्स है, 3 कार्बन्स है, ईथर 2 कार्बन्स. Are you getting or not? Clear? Moving ahead, ethyl, N-ethyl ethanamine. You see, it is ethyl amine CH3, CH2 and NH, and if you write ethyl group over here, C2H5. So, to say it is N-ethyl, nitrogen में ethyl group है. That is how you have to see. Take a pen and paper and practice with us, my dear children. So, let us be, this session supposed to be more interactive session, so that you can talk to me, I can talk to you. And N-methyl propanamine. So, N-methyl propanamine, propanamine कैसे लिख सकता हूँ आप? CH3, CH2 and CH2 and N. So, it is N-methyl propanamine, you can say. So, it is going to be CH3. So, that is N-methyl, N-ethyl. That is how you have to study it. Okay, Belved, Brash and Bhargavi and Anuj Gope, come on, any doubt? Moving ahead here, pentan trione, pentan 2-one, and with respect to this ketone group, 2 carbons are this, 2 carbons are this. With respect to this ketone group, 1 carbon is here, 3 carbons here. So, this is also a metamer. And moving ahead, Tautomerism. Yes, of course, it's a super important and the most avoided and the most confusing topics as far as the student part is concerned. But here, I want to make you unveil how to use this Tautomerism in the simplest way. Tautomerism is a special type of functional isomerism in which there is an equilibrium, dynamic equilibrium exists between shift of one acidic hydrogen from one place to another place. This phenomena is known as Tautomerism or desmotrophism. Actually, this is a Tautomerism and it is a real phenomenon which actually exists. It looks like a resonance, but it is not actually a resonance, it is a dynamic equilibrium. This Tautomerism takes place in the aqueous solutions only. It may be an acid catalyzed or it may be a base catalyzed. Various types of Tautomerisms are there. So, I want to unveil this kind of Tautomerism in various compounds. I want to give an example and I will show you here. So, this Tautomerism, you can say tautomers exist in the dynamic equilibrium, my dear students. It exists in the dynamic equilibrium with each other. You can say there is the condition for the Tautomerism is there should be at least a pi bond, there should be at least a positively charged hydrogen. This is the condition. This hydrogen should be present with this electronegative atom. You can see here, if this is a multiple bond here, this hydrogen is going to be shifted ताकि ये double bond यहाँ पर है shift करना पड़ता है. So you are going to get another functional group here. So tautomerism could be of two types, a diode system and a triode system. Hydrogen is wandering here and there. Anshuman, my voice is low. Vijay Bhargavi, is my voice is clear? Please let me know, let me know, let me know. Is my voice is low? Let me know, let me know. Arre beta, my voice. So those who are online, please like the session once. Yes. Okay, don't worry. The other students, please confirm, is my voice is okay? Arre beta, thoda sa chance de no. You want me to change this? Those other students, please confirm, is my voice is okay? I will change my mic for you. So, is that fine? Is that fine? Now I changed my mic here. Another mic. Okay, let us go ahead with this. Tautomerism is of two types. So maybe your connection is less. Okay, no worries. Automatically your connection is going to be restored. My dear children, it is about a diode tautomerism. The other students, please confirm. Okay, so movement of wandering of hydrogen from atom 1 to atom 2 position. If you say here hydrogen cyanide, HCN. So the hydrogen is going move from atom 1 to atom 2. Don't give the numbering according to IUPAC. I want to say it's the first atom and this is going to be second atom. When this is shifted from here to here, so shifting of hydrogen takes place in the tautomerism. So you're going to see another compound. So HCN, cyanide become isocyanide. What is ultraviolet, catastrophic and Max Planck constant? So we are not, that is not there in the chemistry beta. You can ask your physics faculty, is going to help you. Anshuman Singh, this is the tautomerism. Please participate in the tautomerism. I am requesting, because other students are also waiting to understand this. This is shifting a hydrogen from first place to second place is called as a 1-2 system or diode system. Most of the cases you have triode system. What is a triode system? Diode system, tautomers HCN and NHC. Okay, leave it RCN and NRC. Okay, now triode system is very important. So this triode system, movement of hydrogen from first position to third position, you can say it is acetaldehyde. Okay, and the hydrogen is moving. Okay, so one hydrogen, the hydrogen is moving from here to here. So this is what is called alpha hydrogen. In order to show tautomerism, alpha hydrogen is required condition. Okay, and you see, whenever hydrogen is moving from atom 1, 2, 3 or atom 1, 2, 3, this is called 1, 3 position. So that you are going to see, whenever it is shifted from here to here, it is going to give the H pi bond here. So that a double bond is formed, O become OH. You understand, this is enol form, double bond, and alcohol is there, enol form, and it is called keto form. I don't say this is an aldehyde group, but it is a keto group. So the behavior, the vision of this double bond, the vision of this double bond is in the keto. However, it is an aldehyde group. Okay, so there is an equilibrium exists between keto form and aldehyde form. This is what is called a keto-enol tautomerism. You have various types of tautomerism. In that, keto-enol tautomerism is the most important factor, and we will discuss about that keto-enol tautomerism. And you have usually represented the following functional groups. Condition for tautomerism: there should be a multiple bond between carbon and electronegative atom like oxygen and nitrogen, and there should be at least one alpha hydrogen. These are the two conditions in order to say a compound can show tautomerism or not. Here you can say C double bond O, carbonyls will show tautomerism. C double bond N, imine can show tautomerism. N double bond O, nitrous compounds will tautomerism, and nitro groups also show tautomerism. Dear students, here it is more important, as far as the NEET examination is concerned. We are all here preparing for NEET examination. Okay, so from our side, we are from Infinity-Line YouTube channel, we are trying to give you the best to give this. Students should drive into the dream medical colleges. So let us move ahead about this discussion about the tautomerism here. So condition for tautomerism, उसमें एक condition है usually present here. उसमें condition क्या होगा? Presence of at least one hydrogen atom on sp3 hybridized carbon. That I want to say it is called alpha carbon. Okay, and you can say with respect to this functional group है ना, the carbon directly attached to this carbon with double bond is called sp3. Okay, it is going to give its keto form, gives rise enolic form. This is what is called as a keto-enol tautomerism. So Anuj Gope, right. So Anshuman, अगर कुछ doubt है ना तो पूछना बेटा. Moving ahead, tautomerism is possible if alpha gamma unsaturated carbonyl compound containing as hydrogen at its sp3 carbon, that is called gamma carbon. What is this? With respect to this, it is called alpha carbon, beta carbon, and it is going to be gamma carbon. So this gamma hydrogen is going to be replaced. So it is called as 1,4 tautomerism. Can you believe it? It can happen. Can you believe it? It can happen. Science stuck with fun. Voice is so low. Okay. Okay, Madhya Pradesh ayo. Okay, let us see here. With respect to C double bond O, this is alpha carbon, this is beta carbon, this is gamma carbon. So sometimes gamma carbon can also participate in the tautomerism. And you see, keto-enol tautomerism, a form of tautomerism between carbonyl compound and alpha hydrogen, is in the enol form. So a keto form is going to be converted into enol form. Keto form is converted into enol form. Now this is the keto-enol tautomerism. What will happen again? This hydrogen will come here, it will go back. So there is a dynamic equilibrium. Tautomerism is this only tautomerism. Tautomerism is a special type of isomerism where hydrogen is going to move from alpha carbon to a carbonyl group or any electronegative atom to give rise another functional group, and these functional groups actually exist in the dynamic equilibrium. That phenomena you call it as a tautomerism, isn't it? Anuj, fine. Now moving ahead here, keto form of monocarbonyl. So when this is a keto form, that is the enol form, there is an existence of an equilibrium between the keto and enol. But you see, most of the case when you apply equilibrium principles, keto form is more in this reaction mixture than enol form. By recording is the C double bond O is more stable as compared to C double bond C. मैं क्या बोलना चाहता हूँ, ये कीटो इनॉल टॉटोमेरिज्म में हमेशा कीटो इज जनरली स्टेबल, बट इनॉल कैन बी इन rare cases it is more stable because of maybe intramolecular hydrogen bonding, because of maybe some kind of aromaticity or any stabilizing factors or resonance is introduced. So tautomeric form, keto form, as a result of this C double bond O, the total bond energy comes to be 1500 आसपास में. Idli perform tautomerism अच्छा बात नहीं. Which is more stable? Keto form is more stable. C double bond C की वजह से it is 1450. So you can see as keto form has a more bond energy, I want to say keto form is thermodynamically more stable by 48 kilojoules. NEET examination में ऐसे लॉजिक्स पूछने का संभावना है. Science tech with fun, you accept this. So keto is generally more stable, and also this is a keto form, and one you can see hydrogens that are invisible here, hydrogens that are invisible here, it is going to be here. So it is going to be moved here, so the double bond is shifted here, you are going to get enol here. And you can see it is acetaldehyde and it is going to be vinyl alcohol. It is a keto form, is more stable, 100% will be there because C double bond O is more stable, right? And moving ahead, keto form of acyclic 1,2 dicarbonyl compound is more stable. Now we are into depth of the subject. NEET में ये जैसे टॉपिक्स दे रहा हूँ ना, ये सीधा इस्तेमाल करने का कोशिश करो. So that is keto form of acyclic, this is acyclic 1,2 dicarbonyl. So carbonyl group side by side में है, so that keto is more stable of course as I said, but ये दोनों का बीच में अगर एक CH2 घुसा देंगे मैं और एक कार्बन बनेगा, so और एक मॉलिक्यूल बनेगा. So जैसे मॉलिक्यूल आप देखने का कोशिश करो क्या होगा, you are going to get. However in certain cases, so NEET का catch points बच्चों, NEET का catch points here. However in certain cases, the percentage of enol predominates the percentage of keto. ये ऐसे कैसे होगा, चाहे उसमें नेगेटिव मीसोमेरिक इफेक्ट होगा तो, or if any resonating structures or hyperconjugations comes into the picture, if any intramolecular hydrogen bonding is there, in these cases, only in these cases, enol form is going to be more stable as compared to keto form. So let's see some examples based on that. Okay, I want to say here alpha, beta, gamma, you are going to get a extended resonance. So percentage of enol is directly, polarity is directly proportional to 1 by polarity of the solvent. So if you want to increase the polarity of the solvent, this is going to be the major, and if it is a non-polar solvent, this is going to be the major. So I want to say here, a molecules having 2 carbonyl groups separated by C atom, I mean to say, this is called active methylene group. So whenever C double bond O and CH2 and C double bond O, and this is what is called as active methylene group. And it is acidic in nature. And it is more reactive. It is more reactive as well. Arre. So, if this is going from somewhere to here, hydrogen is gone here, coming down here, so that you are going to get keto to enol. But you see, the equilibrium lies more in the enolic form. Kyunki this is the structure I just want to show you. C O H and double bond CH and C double bond O CH3 and CH3. Now there will be intramolecular hydrogen bonding. Because of the intramolecular hydrogen bonding, it gives extra stability for the molecule beta. That's very, very important, and this is how the intramolecular hydrogen bonding is seen here. This is hydrogen bonding, है ना? More stable due to hydrogen bonding in cyclic form, more stable due to resonance stabilization of conjugated double bonds. So there is a conjugation in the double bonds. So there is a delocalization. Okay, so dear children, and let us talk about only this kind of subject only. So Dhruv, hello, and Sonali Gope, please focus on the subject, because so many students are waiting like you to understand the real essence of the subject. Okay, so any factor stabilizes this carbon to carbon double bond, makes the equilibrium to shift in this forward direction. Agree? Dhruv, any doubt, bacho? Please let me know. Now, keto-enol tautomerism, enol form of cyclic 1,2-dicarbonyl compound is more stable than keto. If it is acyclic, so Rutu, right. So very good. If it is acyclic system, 1,2-dicarbonyl is unstable, while if it is enol form of the cyclic system, 1,2-dicarbonyl is more stable. Why? Because here there is an extension of the hydrogen bonding. You can see this is the structure. Let me write this structure here, and a double bond here, and there is a hydrogen bonding. So intermolecular hydrogen bonding makes it is stable, right beta? Now one more important. So keto form in enol form, you can see the hydrogens present here is going to be moved from here. So it is what is called as 1,4,1,4 enolization. So this is also forming a phenol which introduces aromaticity, makes it is 100% stable. Okay, Dhruvan, Adi Dhruvan, hello. Okay, Rutu, please like the session beta. Please like the session. Those who are online, please subscribe to this channel, so that this kind of videos will be, we are making and give you the best during the NEET examination preparation. Everybody, ek bar subscription button dabao. Once you please make a subscription button. So hi, Nestler's reagent अभी मध्य प्रदेश आए हैं. Okay, very good. Nestler's reagent का formula क्या होगा? K2HgI4, and this is used for detection and confirmation of ammonia and ammonium ion qualitative analysis. Making here, my dear children, here percentage of enol increases with the stability of alkane. Any factor which stabilizes the C double bond C can increases the enol content. Okay, very good. Please like the session beta. Rutu, like the session. Nestler's reagent, please like the session and subscribe to this channel. Those who are online, please like the session, subscribe to this channel, so that our video visibility will be increased. हम पैसा कमाना के लिए नहीं आ रहा हूँ, Okay, to increase the visibility only we are requesting you to like the session and subscribe to the channel. Nothing more than that. Okay, you see CH3CHO, it is a keto form, it is converting into enol. It is a keto form converting into enol, keto form converting into enol. In these three structures, here enolization is here more. Why? Because hyperconjugation is going to be more. Any factor which increases the stability of C double bond C. What are the factors that increases the stability of this alkene is nothing but your hyperconjugation, resonance and all. Our favorite hai na. I have so many students from MP. My colleagues, many colleagues are there from MP. I love all students in all over India. Okay, and you know, one student is talking about here, Dhruv, Adi Dhruvan, please ask your doubt. Okay, so NEET examination, you will be asking you such question. Okay, the order of enolization, conversion of keto form to enol form is called as enolization. More stable the enol form is, the more is the enolization process, faster is the enolization process. So that the reaction is, the question is going to be asked in such a way that which of the following is the correct order of enolization. Simply write that keto form to enol form is written, and you check the structure of enolic structure. If more hyperconjugation structures are there, it is going to be more stable, so that rate of enolization 3 is greater than 2 is greater than 1. This kind of questions you can expect from the NEET examination. So fine, any doubt? Fine. Now let us see one more. So general percentage of enol content, it is a super awesome trick for NEET examination. You can directly use it. Aromatic is greater than dicarbonyl, okay, is greater than alpha dicarbonyl and monocarbonyl. What is beta dicarbonyl? So 2C double bond वो groups है ना, ये CH2 separate करता है. It is what is called beta dicarbonyl. Are you getting or not? Any doubt बच्चों? That's good. Perfect. Now talking about how to decide the type of isomerism if multiple types are possible. It's a super important thing. Again it is a trick. आज का सेशन में क्या बोलना है? नीट एग्जामिनेशन का क्विक एंड फास्ट ट्रैक स्ट्रैटेजी है आज. ओके, आइसोमेरिज्म फास्ट ट्रैक स्ट्रैटेजी. ओके, live streaming you are going to see if more than one type of isomerism is there. So कौन सा पकड़ना? RTF-MCP. What is R? That is ring chain isomerism. And Tautomerism, functional isomerism, Metamerism, chain isomerism, position isomerism. RTF-MCP is the trick. You can use it to decide which type of isomerism it is going to give you. Right? Fine, beta. So, degree of unsaturation. So, actually, this is the key point. Degree of unsaturation. So difference in the number of pairs of hydrogen atom between the compound under study from a cyclic alkane having the same number of carbon atoms. So this is otherwise called DBE double bond equivalent or index of hydrogen deficiency. So it gives you why degree of unsaturation NCERT में नहीं है, बट लेकिन आप इस्तेमाल करना है क्योंकि ये मॉलिक्यूलर फार्मूला आपको देता है. ये मॉलिक्यूलर फार्मूला के हिसाब से कौन सा स्ट्रक्चर सब बना सकते हैं. दैट इज बेस्ड ऑन डिग्री ऑफ अनसैचुरेशन DU और डबल बॉन्ड इक्विवेलेंट. सो यू कैन से इट इज अ फार्मूला. यू कैन से इफ मान के चलो a formula CaHbXcNdOe, where X is a halogen, N nitrogen, oxygen, E. Degree of unsaturation is equal to A plus 1 minus B plus C minus D by 2. So, if you say this degree of unsaturation, what you are going to expect it? So, interpretation, so application of degree of unsaturation. You see, degree of unsaturation अगर 1 होगा तो 1 pi bond भी होगा और उसमें 1 ring भी होगा. Avenger अभी आएगा तो कैसे समझेगा बेटा? Okay. So, if degree of unsaturation is 2, you can get either 2 pi bonds or 1 pi bond and 1 ring or 2 rings in that. So, like that you can make your own structures based on this degree of unsaturation. So, you have various things. You can say, remember the following compounds do not exist at room temperature, because therefore are not considered as a structural isomers. Whenever you are writing a structures from a given molecular formula, please avoid this, because room temperature में stable नहीं है. A keto form होगा, Enol actually will not be there, and triple bond with OH, double bond with OH, and 2 OH groups on the same carbon atom never and ever be stable. Any peroxy compound also you cannot do it. So, it is maybe you are writing your CBS examination. So, how to write this corresponding molecular formula and the structures? हाँ नहीं ना sir, 1 hour है ना? नहीं, it is not like that. You could have asked the doubt right from the beginning. No worries, you can watch the recording. If you have any doubts, you can just mention in the chat box. You can mention in the comment box. I am going to start that review of this session, and I can give you direct answer in that where you missed it also. So, like that, so many structures you can get rid of this, and you can write the structures by yourself, right? So, moving ahead, a long way to go, bachcho, a long way to go. And as the time is exhausted, we will be discussing these things again in the part 2, and we will talk about multiple choice question based on the NEET examination. ठीक है बेटा? Now, as the time is being exhausted, we shall close the session and we'll meet with more stuff in the next class. Thank you very much. Like the session, okay, and please subscribe to Infinity Lane NEET YouTube channel, and please share these things with your friends as well. उन लोगों को बेफायदा होना चाहिए. Okay, thank you very much. See you. Bye bye. God bless you. Signing off, Suresh, Faculty of Chemistry. Thank you.